Hello everyone, our project for today is priority scheduling, and the title of this project is describe the function of this algorithm. Priority scheduling is an algorithm of scheduling processes depending on their priority. There is an integer number associated with each process, and this number indicates the level of the priority of the process. And the scheduler select highest priority job over the lowest one. Like if we have number from 1 to 5, then number 1 is the highest priority and is gonna execute it first. The largest CPU burst lower the priority. What is the CPU burst? CPU burst is the amount of time for the process to be executed on the CPU, and the biggest this amount of time lower the priority of the process in the CPU. There are some factors that decide the priority of the process. These factors can be divided into time requirements and memory requirements. Time requirements means if there is a priority, if there is a process that needs to be as soon as possible, this means this process have the highest priority. And the memory requirements indicate the capacity of memory need to accommodate certain process. So in such situation we need to prioritize the process according to that capacity. Now what if we have two processes that have the same priority? In such situation we're gonna treat the process as first come first serve. Like the process that arrive first is gonna be executed first. SGF is shortest job first and is a special kind of priority scheduling algorithm, and in this algorithm where the shortest process that the process have the shortest time first is gonna be executed first. So it's a special kind of priority algorithm. As we mentioned earlier, there are some factors that decide the priority scheduling, and according to these factors, the priority scheduling is divided into two types. There is internal priority and then there is external priority. Internal priority is computed based on time limits, and we explained it before as if we have a process that has to be soon, then this process have the highest priority. Memory requirements is referred to memory capacity to accommodate certain process. So according to that capacity, we prioritize the process. Ratio of average is referred to process and the burst time and the waiting time, and this is some calculation. We're gonna go through it in one of the slide below. And then there is a input output burst to average, and input output burst actually the CPU when the CPU is waiting for the input output burst to be executed on the CPU. CPU burst also explained it before. CPU burst is the amount of time for the process to be executed. The other type of priority scheduling is external priority. And external priority is set by criteria that are external to operating system, which is different from internal priority. The first factor of external priority is the importance of process. Like if there is a process that is more important than the other process, then this process have the highest priority. The second factor is the type or amount of fund being paid for computer use. So according to that amount of funds, we're gonna prioritize certain process to be the highest priority. The department is sponsoring the work, so also according to that department, we're gonna prioritize the process that have more sponsorship. Politics could deviate right or left, so according to that deviation we're gonna prioritize the process. Now we're gonna have an example to illustrate the priority scheduling, and in this example we have three columns. The first column is the processes, and we have five processes: P1, P2, P3, P4, and P5. And we have a press time column too. We have five numbers which indicate the press time of these processes, and the third column is the priority, also indicate the priority time of the processes. To illustrate this algorithm, we use Gantt chart, and actually Gantt chart is a chart that founded by Henry Gantt in 1910 to illustrate the start and finish dates of the terminal elements and the summary of a certain project. So to illustrate or to make it clear to understand this algorithm, we're gonna see the first priority process. If we look here, we're gonna find it P2. So we're gonna locate P2 on the chart, and then we're gonna look at the first time of this process. We're gonna find it 1. The second priority, we're gonna look at the priority. We're gonna find the second priority is P5, and the first time of P5 is 5. So we're gonna add 5 to 1. The waiting time would be 6. The third priority is P1, and the first time of P1 is 10. So we're gonna add 10 to 1 plus 5. We're gonna be 6. The next one is the fourth highest priority is P3, and the first time of P3 is 2. So we're gonna add 2 to 16. We're gonna be 18. The least highest priority, number 5, is P4, and the first time as P4 is 1. So we're gonna add 1 to 18. Is gonna be 19. So to calculate the average waiting time, we're gonna just sum all this waiting time and divide it by the number of this process, which is 5, is gonna be 8.2. So that's how we calculate the priority scheduling algorithm. I hope it's clear for you. Now in this section, we're gonna go through the advantage of this algorithm, priority scheduling algorithm, and one of the advantage is a reasonable support for priority, and that's why the algorithm is here, I think, to support the priority. And actually the priority, as we went before, there is external factor for that priority, and there is internal factor for that priority, and we went through it in the past slides. Another factor for another advantage of this algorithm is suitable for application with varying time and resource requirements. And also we went through that there's a different process with different times, with varying time, and we know how to prioritize the process according to that different times. Also, it's a good mechanism where the relative importance of each process may be precisely defined. Like one of the factors that define the priority of the process is importance of the process. So we saw here in this illustration how the most important process is going to prioritize over the least important process. Simplicity, also, as we went through the example that we just saw on the last example, we saw how to calculate the priority algorithm, and we saw how it is very simple to do that. As we went through the advantage of priority scheduling algorithm, we're gonna go through also disadvantage of this algorithm. One of the disadvantages of this algorithm is indefinite blocking or starvation, and actually in the next slides we're gonna explain what is starvation, because it's one of the problems that face the execution of the priority scheduling algorithm. A priority scheduling can leave some low priority waiting processes indefinitely for CPU. and this is also one of the problem, because since we just let the low priority waiting process indefinitely for CPU, then this is a problem to execute this algorithm. If the system eventually crashes, then all unfinished low priority process gets lost. So all this unfinished low priority is gonna just lost. And another problem in deciding which process should get which priority level assigned to it. Like, it's a problem itself to prioritize which process would be first and which process would be second and third and so on.